Hello, all. Today we'll be looking at a thing called genetic algorithms. So we are kind of going into stuff like what to say, machine learning stuff. So whereas the genetic algorithms, lots. Okay, driving a car with genetic algorithm. So I encourage you to see this video. I hope, yeah, like I don't run into copyright stuff. So I encourage you to see this video. So let me just mute it and just tell you. So here a car is just driving down the track, okay, and it all seems fine. And now, yeah, look, this is the sensors in car that measure the distance, like the front distance, the right, left, and something between the front and right, and front and left, and all those. And the car crashes and all those stuff. So how the author gets to, okay, let's say uh, oh my God, this YouTube and ads and all this stuff. Okay, yeah. So how the author gets to do this is he creates hundreds of cars, okay, and some of them drive into the walls, and some of them just somehow just go to some distance. Okay, so that's how he just. So yeah, maybe these cars are just doing good. Okay, so what he's just doing is like, yeah, he's just picking the car that really does good, and what he's doing is like he's iterating again. So the one that does good, okay, like you just change some attributes in it, like it's just like genes, you just change some attributes in it. Some might do really better, okay, like the ones, yeah, that are here, these are all doing better, these are doing way better and all those stuff, right? This is doing way better, I just think. Okay, so some just do way better and some do worse, like I think like some went reverse and all those stuff. So he's just choosing the car that has done way better, and once again he's just iterating some parameters. Okay, so that will do far more better. Okay, so like, okay, yeah, so that will just do far more better. And okay, so yeah, like, yeah, so this is doing, I think, far more better. So that's how it is. Now he just chooses the car that does really better, yeah, far more. So that's how it is. Like he just keeps choosing the cars that does better, and he just changes some parameters in them, like the steering and velocity parameters and all those stuff. And somehow the one, and so by each and every successive generation, the car keeps on doing it better. Okay, so now we are going to see how, what to say, this guy does it. Okay, like let me just fast forward and do it. So now the cars are going to, yeah, it has almost completed the track. Some cars aren't even going anywhere. Okay, so that's how it is. So yeah, he's choosing the cars that have really, what to say, really going through the track. Okay, so that's how it is. So yeah, so finally he ends up with a car that really drives well and all those stuff. And it sometimes it even races, like it even goes faster and all those stuff. So this is how even organisms evolve. Like there are billions of organisms that die for, or millions at least, or thousands at least, that die for one successful one. So that's how it is. And even we humans are like that. Like the most successful humans, unfortunately, the most successful humans are going to survive, and those who are not might not. So like, for example, even the corona outbreak. So the people who have genes to survive did survive, and people who don't have, okay, and yeah, of course, it's a combination of genes, vaccines, and all those stuff. If you're vaccinated, you have a better chance of survival. So here intelligence also comes into play. So let me tell you how the author would have done it. Okay, so we have velocity of the car that's been given by a formula sigma of alpha I di, where di is the distance from the car to the barriers or something. If the car is over here, right, the distance will be like this one, d1, d2, d3, d4, and all those stuff. Okay. So similarly, angle of turning is like beta I di. So imagine like okay, like there is lot of this sensor that's the D3 sensor that says like there is lot of what to say distance between this and the barrier. Let's say the car is over here looking like this, so the barrier is so distance away, right? So let's say like we have a equation for okay, this car driving. I'll just put uh, rename. Yeah, my naming is not consistent. I should have put something like capital or something like that. Yeah, let me just rename and all that stuff. I just want to bring in some kind of consistency. Of course, like this and all you won't learn in okay, like in the beginner's course or something like that. But yeah, like it's better to have it, right? So the velocity, let's have something like okay, like v of okay, uh, d1, d2, d3, d4, d5. Okay, so something like okay, like okay, 5 d3 or something like that. Okay, okay, like let's this all be in meters. So if like 0.1 d3, okay, if the distance between like the car and okay, if the distance is what to say like 10 meters, the car velocity will be like 1 meter per second or something like that. So it'll at least take 10 seconds to crash or something like that. Okay, so if it's going to crash near some barrier, so yeah, like that's how it is. So let's say like so now no matter whatever we give in d1 d2 like okay 2 meters, 5 meters, 10 meters, 4 meters, 7 meters. Okay. And so we just see, okay, the velocity is 1. Now, let's say change the velocity a bit, like, okay, 0.23. And I just want, let's say, like, okay, if D4 and, okay, let me just reverse this because, like, okay, I've put D5, D4, D3, D2, and D1. Okay. And before that, let me just put a cell. Okay. Like put a cell here that's marked down. And in this, let me put this image right, so that you will. Okay. Right. Okay, so you have just got it. Okay, so the car image is there, and that's how it is. So now we are just only taking D3 for the velocity. Okay, so now let's even include this one D4 and D2. Okay, so like point not 0.05. Okay, like D4 plus 0.05. Okay, I'm more interested in the steering rather than velocity. Okay, yeah, so okay, D4 and then what is over here? D2. Okay, D2. Okay, so what happens is okay, now even if the future roads are wider, then the velocity slightly increases. Okay, so that's how it is. So now if we just put okay, like yeah, I need to rerun this, right? Now, if you put the velocity slightly increases, and if the future road lengths decrease, like let's say we are going in a very, very narrow road, like where it's just 1 meter and 1 meter, but yeah, still the distance, like the crashing distance is still 10 meters. Now the velocity decreases. Okay, so the car might have something to steer or something like that, and all this stuff. And yeah, like let's say like I'm just approaching, I'm just going to hit the barrier. Okay, so now the velocity decreases. Now okay, like let's say put 5 and something like that, and now 3 meters. Now it almost the velocity is almost becoming like 0.4 meters per second. So 0.4 meters, that by 3 meters is like how much? Like 3 by 0.4. It's going to take 7.5 seconds to crash. Okay, so that's how it is. Like so the car keeps slowing down and down and down as it goes about to crash. Okay, let's say like now like the velocity is like 10 d3 or something like that. Okay, so now what happens is now the car crashes in. before anything could react, the car will just crash. Okay, it's just going to crash in point not 1 second. So possibly those with the thing like okay, something like okay, like 0.1. Okay, sorry. Okay, so yeah, I should actually have put like okay, 10 D3. Okay, yeah. So now let's say like okay, so yeah, 0.1 D3 seems to be something like we think it's ideal, but I don't know. In this real racetrack, we really don't know. Okay, so the car gets time as it's going to crash through the barrier. Like the car just slows down, so it almost doesn't crash. Okay, so that's how it is. Okay, uh, so, uh, so yeah, this is how the velocity would have been determined, and possibly like something. This equation would be something like ideal to drive. But yeah, I'm a human. I can see a lot. I know a lot of things are there in mind. But in genetic algorithms, it needs to do trial and error. So we will be looking at it in one of the things where we'll be guessing a number with genetic algorithms and all those stuff. So first, it might even start with like something like 200 D3 or something like that, 10 D3 or something like that. Okay, 10 D3, what to say, 5 D4 and something like that, and immediately it'll crash. Okay, okay. Let me put 35. Okay, right. So it'll just crash in 0.857 seconds or something like that. It'll just go somewhere and crash. Very high speed cars, just like drunken driving. Okay, so yeah, that won't work. And something like you, and slowly it will evolve into something like this one, 0.1 B3 or something like that, and then so this will all prevent crashing. Okay, so that's how it is. And even this 5 D4 is high, so it might evolve to 0.5, and yeah, that seems bit optimal, 0.85. So let me put 0.85. So it'll crash in another 3 seconds or something like that. So if you put something like, okay, 0.1 over here, so, okay, 0.45, okay, right. It'll crash in 6 seconds, okay. This looks, okay, far more better. Okay, so that's how it is. So this is how the velocity equation would have been determined. And the angle, okay, angle also is like surprisingly almost the same formula, but yeah, different constants, okay. So let me show you how. Okay, so copy image link. Okay, I'll make this as markdown. So I'll just put the image. Yeah, if you want, you can go and read about markdown. So what it is and how to do it. It might be useful. Okay, so yeah. So over here, this is there. And imagine like angle we are measuring like this one. Like this one. Okay, right? So, or for you people, if you are looking like this one. So as it goes like this one, we are measuring it in positive. So if you go like this one, like this, it'll go negative. Okay, so counterclockwise is positive, clockwise is negative. Okay, so that's what we are measuring angle. So now the car is going to hit this barrier. Okay, let's say like this is an infinite barrier. The car is just going straight and it's going to hit this barrier. Okay, so actually the car should steer left. Okay, so for that, okay, D1 and D2 are what to say. Uh, so decreasing, and possibly D4 and D5 might be increasing. Okay, and D3 will also be decreasing. I think like if the barrier is kind of infinite barrier that keeps stretching all over here. Okay, so that's the thing. So I mean all over here on the cells and all those stuff, right? So what happens is like, okay, if we have negative beta for D1 and D4, so beta 1, sorry, D1 and D2. So beta 1 and beta 2 are negative. Okay, so when D1, D2 decreases, the angle decreases. Okay, so because the negativity decreases, right? So this is okay. Angle measure is okay. The left turning is positivity, the right turning is negativity. So if the negativity decreases, then it will turn more. So D4 and D5 are increasing. So if the beta over here is positive, it will just turn left. So for at least turning left, okay, this is the ideal thing. Okay, but I think I think the ideal thing will be like the angle. I'll just put like okay, theta, theta, yeah, theta of Okay, like D5, D4, D3, D2, D1. Okay, is equal to, I'll just put something like, okay, like when the car is almost, okay, like I'll just put like, okay, like 5, D5, D5, and what to say, 10, D4. Okay, I don't want to include D3 over here because I don't think the angle of turning depends on D3. Okay, so it's just 0. So no need to include D3 over here. But anyway, I'll just put 0 D3. Okay, right? 0 D3. Okay. And then, okay, once again, I'll just put like 5 D2. 5 D2. And then 10 D1. Okay, okay, minus 5 D2. Okay, so minus 5 D2. Minus 5 D2. Minus 10 D1. Okay, so this is the kind of thing I would like. Okay, so if let's say like, okay, uh, the D5 and D4 are 5 meters. Okay, so D5 and, okay, D5 is 5 meters. D4 is kind of, okay, let's say 7 meters. Okay, D3 is like 3 meters. D2 is like, okay, like what to say, it's going to hit something. So like 0.5 meters, and then D1 is like 0.7 meters. Okay, so now the angle is 85.5. It really turns like this. Okay, that is positive. So it just really turns left. Okay, so that's the thing. Okay, so that's how it is. And now let me just reverse this. Okay, so let's imagine like the barrier is appearing near this D4 D5. So I'll just reverse this. Okay, so I'll just make this as 0.5 and 0.7. Let me keep this as 3 itself. And then D2 and D1 are increasing. Okay, so that's how it is. Now look, minus 85.5. So minus means the car should turn right. Okay, so anything that's counter clockwise is minus angle. Anything that's yeah, counterclockwise is positive angle. Okay, clockwise is minus, counterclockwise is positive. So you just see like, okay, now it's just minus. So let's say like, okay, like if the D5 and D4 are reducing, the car turns clockwise and this one turns anti-clockwise. Uh, so like, yeah, many cars have been formed, and many with many constants of this thing, like these constants we call them as betas and all those stuff, right? And with many alphas, and one that goes really well is getting selected, and then we just increment it slightly. Okay, with one good car we make another 100 cars. Okay, one slightly better than uh, okay, one slightly better, one slightly worse, and all those stuff. And the best of those has been picked up once again, and that spawns hundreds of another cars with slight changes. Like let's say another car will be, a slight change might be like, okay, like 4.5 d5 or something like that, right? So okay, so now the theta will be like this, now the theta will be like this. So it's just more to the right than left. Okay, so that's how it is. So this is how the equation just evolves, and something like that. And the best equation has been found out, and the author selects the best car. So yeah, that's how it is. But yeah, we'll be writing a program where we'll be guessing a number with genetic algorithm. So right, and then I'll also do something like guessing a line. Like we'll be having some data points, and we'll be trying to fit a curve in that. So like that is a line, like mx plus c, like a straight line. Okay. So yeah, so this is guessing a number with genetic algorithm. This I'm just going to teach you. So hopefully, yeah, like I think this is going to be a long video. So So yeah, like I hope you just get it. So, but yeah, like let's see, like how it is. Before that, yeah, I need to teach plots. So because you need to know basic plotting and all those stuff. So I need to teach plots. So that's how it is. I hope yeah, like you kind of understood and kind of like this video kindled you into machine learning and all those stuff. So let's see, like, let's see in next video, we are going into machine learning stuff. It doesn't mean that I will stop Julia thing. There is a lot to learn in Julia and all those stuff. I'll also be introducing Julia stuff and all those things. And yeah, now we are just going into machine learning. Things are getting exciting. Yeah. Thanks for watching. Bye.